everyone. This is your Gayatri madam. Here I am starting a very interesting and very important topic, that is higher order differential equation. This is very important in BTech. First, let us see the general definition of higher order differential equation. An equation of the form d power n into y by dx power n plus p1 of x into d power n minus 1 into y by dx power n minus 1 plus p2 of x into d power n minus 2 into y by dx power n minus 2 plus and so on plus pn of y equals to q of x is called the linear differential equation of nth order. So, what do you mean by linear differential equation? It is already taught in first order linear differential equation. Nth order, this is called the linear differential equation of nth order or nth order linear differential equation, where p1 of x, here the coefficients for each and every term, the coefficients are p1 of x, p2 of x and so on, pn of x, are real valued functions of x. Suppose sometimes p1 of x, p2 of x are not in terms of x. Sometimes it may constants. That is an equation d power n y by dx power n plus p1 d power n minus 1 by dx power n minus 1 plus p2 d power n minus 2 y by dx power n minus 2 plus and so on pn y equals to q of x is also called the nth order linear differential equation, but here p1 p2 are constant coefficients. So here we are going to solve these differential equation, these nth order differential equations. See here two types of nth order differential equations are there. First one is here you are seeing, first one is p1 of p2 of x and so on pn of x are functions of x. So that means the coefficients may be in functions of x. And here the second differential equation where p1, p2 and so on pn are constant coefficients. So we are solving the differential equations which consisting of constant coefficients which contains functions of x. We have to solve both the types of differential equations. First, we are going to consider the nth order differential equation which contains the constant coefficients. Let us see the problems how to solve. After that, we go to for the we go to solve the differential equations of coefficient which contains the coefficients are in terms of x. So let us see what is the order and degree of the differential equations. I think you know when you are solving the first order differential equations what is the degree and what is the order. So here order is nothing but the highest derivative of the differential equation. So here in this differential equation the highest derivative is n, d power n y by dx power n. So that's why we call this differential equation is nth order differential equation. Okay, and coming to the next one. For example, d square y by dx square plus 3 into dy by dx plus 3 into dy by dx plus 2y equals to x square. Here, this is a differential equation contains the constant coefficients. It is a differential equation of order. What is the order of this differential equation? 2. Because the highest derivative involved in this differential equation is 2. So, the order of this differential equation is 2. So, we call it as the second order differential equation. So, we have to solve this unit. We are going to learn how to solve this type of differential equation. So, first we are learning that what is the order. First we have to, after giving the problem, we have to understand what is the order of this differential equation. So, what is the solution we have to find. So now coming to the second example, d cube y by dx cube plus 9 into d square y by dx square plus 7 into dy by dx plus 63 into y equals to e power 2x. So what is the order of this differential equation? 3. Since because the highest derivative in this differential equation is 3. So third order differential equation. Now the solution of this differential equation, normally the general differential equation, what I said, d power n into y by dx power n plus p1 into d power n minus 1 into y by dx power n minus 1 plus and so on plus pn of y into equals y, pn of y equals to q of x. Okay, this is the general nth order differential equation. The solution, the solution is of the form here. In this differential equation, what is the dependent variable, what is the independent variable? Here y is the dependent variable and x is the independent variable, right? See here, x is the independent variable and y is the dependent variable. So the solution means what we are going to find? We are eliminating the derivatives. We are eliminating the derivative so that we get the solution is of the form dependent variable equals to in terms of independent variable. Dependent variable equals to in terms of independent variable. This is the solution of the form. So we get here arbitrary constant. So the solution of the linear differential equation is of the form already we have solved in the first order differential equations. I think you know guys, the first order differential equation. What is the first order differential equation? The differential equation contains first derivative. So the solution is of the form the dependent variable. Here the equation is in terms of dy by dx. Y is dependent variable, x is independent variable. Sometimes we get the differential equation like d power n into x by dt power n plus p1 into d power n minus 1 into x by dx power t minus 1 and so on plus q of e and so on plus pn of into x equals to q of t. This is also differential equation of nth order. But here the dependent variable is x. This is dependent variable. This is independent variable. So what is the solution for this equation? This differential equation, dependent variable equals to in terms of independent variable plus arbitrary constant. So this is the solution. This is the general solution. We call it as the general solution of the differential equation is of the form dependent variable equals to in terms of independent variable. So how to get this solution, this general solution, we are going to learn here. Okay, I hope everyone understood what is the differential equation, what is the general definition of the differential equation of order n, and what is the general solution for that differential equation. So that is dependent variable equals to in terms of independent variable. Okay, now let's see the next ways to solve this differential equation. What is the procedure we are following? So here I am taking one example. So first we have to take the differential equation. Example I am taking here. So d square y by dx square plus 3 into dy by dx plus 5 into y equals to some x square. So I think you know guys, this is the second order differential equation. To solve this differential equation, we are taking, put d by dx equals to take capital D. Here the dependent variable is x. So we are taking d by dx, the derivative d by dx equals to d. This is first time derivative. In the same way, d square by dx square, you consider it as a d square. And d cube by dx cube equals to take it as d cube and so on. So whatever the derivatives involved in the differential equation, we have to consider like this. So in this the problem we have d square y by dx square. So put d square by dx square plus you put d square. So that implies d square and what is the remaining one? y plus 3 into, here d by dx is there. So put, instead of d by dx, you put d. 3 into d and remaining y is there. So y plus 5 into y equals to x square. Okay. Now take y outside from each and every term. So d square plus 3d plus 5 into y equals to x square. Okay. So now this is of the form, we call this is of the form f of d. Here this is totally, it is in terms of d, right? So is of the form, now it is of the form f of d into y. F of d into y equals to q of x. So till now what we done? The given differential equation, we are converting the given differential equation is into the form f of d into y equals to q of x. So where f of d equals to d square plus 3d plus 5. So the given differential equation, what is the first step we should do? The given differential equation we have to convert into f of d into y form by putting d by dx equals to d square by dx square equals to d square, d cube by dx cube equals to dx cube, and so on, d power n by dx power n equals to d power n. Okay. So now after writing into f of d into y equals to q of x, now we have to find the solution. The solution, general solution, as I told, that dependent variable equals to in terms of independent variable plus arbitrary constant, like, right? So this solution is converting, we have to find in two parts, like yc plus yp. Okay, that means the general solution is of the form y equals to yc plus yp. See, yc means complementary function, yp means particular integral. Yc we solve from the left side part. By considering the left side part of the given problem, we find yc. By considering the right side part, we find the yp. So the yc plus yp is nothing but the general solution y. Okay. So now how to find yc? First, let us know how to find yc. Yc means complementary function. So here we have so many types of the complementary functions. See here. By taking here f of d, what is the f of d here? We got d square plus 3d plus 5 plus 5 plus 5 equals to plus 5. This is f of d only. That is q of x equals to x square. Now, to find the complementary function, complementary function, take the auxiliary equation. This is very important. Take the auxiliary equation. What is the auxiliary equation? The auxiliary equation is f of m equals to 0. Already we know f of d, and find f of m. Write f of m and equate to that value, equate to 0. So f of d equals to d square plus 3d plus 5. Then f of m is nothing but m square plus 3m plus 5 equals to 0. Now find the roots of this equation. We get the m values. So the roots are, now we have to find the roots. This is second order equation or quadratic equation. Quadratic equation, how many roots we may get? 2 roots. If it is cubic, then we get 3 roots. If it is m power 4, then we get 4 roots. So all the roots depends on this equation. So here this is second order equation. So we call it as we will get 2 number of roots. So the roots may be here, the roots are different ways we get. First one is roots are real and different, and second one is roots are real and equal, and third one is roots are complex roots complex roots, and fourth one is roots are some are real, some roots are different roots, and some roots are equal roots. Okay, and that combination of these we make it. So these are the types of roots. So if we get the roots are real and different, what is the complementary function, how the way we have to write? If the roots are real and equal, how the way to write the complementary function? If the roots are complex roots, how the way we have to write the complementary function? So let us see now. Okay, so now see, roots, everyone write, everyone follow, regularly follow my videos, and you maintain your notes as usual. If you like my video, give me like and subscribe my channel. So now coming to the topic, roots and complementary functions. Suppose first one, if the real roots are real and different, if the roots are real and different, then how to write the complementary function? Suppose I get the roots are m1 comma m2 comma m3. I get the roots, three roots. Three roots are real roots and different. So how to write the complementary function for this? Yc or Cf you can put. Yc equals to c1 e power m1x. For three roots, we have to take three arbitrary constants, C1, C2 and C3. Three different roots, you can put C1 plus C2 plus C3. So for first root, C1 into e power m1x plus C2 into e power m2x plus C3 into e power m3x. Okay. Now next, second one. If the roots are real and equal, roots are real and equal. So equal roots, that may be m comma m comma m. M is repeating three times. How many times it is repeating? Three times. So how to write the complementary function if the roots are real and equal? Yc equals to, so total how many roots I have? Three roots. So that means I have to take three arbitrary constants. Three arbitrary constants. But three roots are equal roots. So C1 plus C2x plus C3x square into, for all these three we have to write one root. So e power mx. Okay. If the roots are equal, and it is repeating four times, roots are repeating and it is four times it is repeating. Suppose example I am taking, I am getting m is 2 comma 2 comma 2 comma 2, four times it is repeating. So how to write the yc equals to four roots are there, so you have to take four arbitrary constants c2, c3 and c4. For first, it is x power 0, x power 1, x power 2, x cube. So, into e power 2x. So, that's why x power 0 is 1. So, we can directly take c1 plus c2x plus c3x square plus c4x cube into e power 2x. We can take yc function like this. So, this is the way to write the complementary function, depends on the roots. So till now I completed two types of the roots. First one is roots are real and equal. Then we have to take complementary function such a way. So if the roots are real and equal, we have to take the complementary function in such a way. So now coming to the third one, suppose if the roots are some roots are different, some roots are some roots are equal. That is, suppose example, m1 comma m2 are different and m comma m 3 times repeated. So total I have 5 roots. So 2 roots are different here. m1 comma m2 are different. M is repeating 3 times. So how to write the complementary function? For different roots you have to take like this, and for equal roots you have to take this one. This is the combination of both. So for first you can take equal, and second you can take different, or first you can take different and second you can take equal. Anyway you can take. So first here I am taking, I'll show both the ways. C1 plus 2 roots are different. So for 2 arbitrary constant I am taking C1 into e power m1x plus C2 into e power m2x. Next, m is repeating 3 times. So 3 arbitrary constant you have to take. Already C1, C2 completed. So C3 plus C4 plus C5. Okay. So it is repeating e power mx. So C3 plus C4x into C5x square into e power mx. Or else you can take like this. C1 plus C2x plus C3x square into e power mx plus C1 into e power m1x plus C2 into e power m2x. Like this also you can write the complementary function. Now fourth one is roots are complex roots. Suppose roots are complex. Roots are complex. So you know that complex root is of the form m equals to, suppose m is the root that is in the form a plus r minus ib form. So the complex member is a plus r minus ib. So if the root is of this form, how to write yc? Yc equals to a is the real part and b is the imaginary part. So yc equals to e power ax into c1 cos bx plus c2 sin bx. See, here why we are taking 2 arbitrary constant? You may get a doubt here too. I have taken 2 arbitrary constant, but here m is only one value you are right. We are taking, but I am taking 2 arbitrary constant. See, observe carefully. M equals to a plus r minus ib. That means a plus ib is one root, a minus ib is another root. Okay, so a plus ib is one root and a minus ib is one root. So 2 roots I have totally here. So for 2 roots I am taking 2 arbitrary constants C1 and C2. Okay. So now coming to the next one. Suppose fifth, roots and complementary function. Now fifth form. One root is real, and another root is complex, and another one is complex. Another one is complex root. That means m1 comma m2. 2 different roots are, it is repeating same roots. It may be same roots, anything. So another one is a plus r minus ib. So now tell me how many roots we have here? 1, 2 plus with plus 1 root with minus another root. So total here we have 4 roots. So how to write the complementary function? Here yc equals to c1 for real root I am taking here real and different roots. So c1 e power m1x plus c2 into e power m2x. For the complex root you have to take e power ax into already c1 c2 done. So c3 cos bx plus c4 sin bx. Don't get confused. By practice you will get immediately how to write the complementary function, or you can take for uh, complex root you can write first, for different roots, real roots, you can write later. Anyway you can write. Now sixth one is, if the complex roots are repeated, okay, complex roots are complex roots, and it is repeating, and it is repeating, that means a plus or minus ib whole square. Okay, a plus or minus ib whole square, that is a plus or minus ib, a plus or minus ib. So total how many roots we have? 4 roots here, 4 roots. So how to write the complementary function? Yc equals to e power ax. Here it is repeating, a plus or minus ib is repeating 2 times, so e power ax c1 plus c2 x into cos bx, okay, plus c3 plus c4 x into sin bx, c3 plus c4 x into sin bx. This is the way to write the complementary function, depends on the roots. Okay, I hope everyone understood. If you like my video, subscribe my channel, and regularly you can follow this unit. Thank you. Next session I will explain the examples of these complementary functions by taking some problems. Thank you.